Hi, welcome to the hijax setup video. Let's get set up. So we're going to need to go to the hijax GitHub repository, which is called github.com/mathematical, which is my username, and hijax. And this repository contains all of the code that is used in hijax, including the starting point for all of the lectures in these lecture folders, and then the ending point we get to in the lectures in the corresponding solution folders. Now, you might want to work in your own version of this repository, so you might like to use the fork button to create your own fork. And that means that you'll be able to use Git and GitHub to track your own progress through the course, and also other people will be able to see your version of the code through the forks list on the repository. But since I'm the author of hijax, I'm just going to work in the repository directly. So I'm going to copy the command from here to clone my repository. And so I'll do that. I'm in my quests folder, which is my personal folder on my hard drive where I put all of my projects, and I'm going to git clone the hijax repository. This will take a moment to download because the hijax repository contains a bunch of data that we'll be using to train some neural networks, as well as these lovely animations, which are sometimes up to a few megabytes to store sort of the demo of the result of what we're building together. But it's only 22 megabytes, and so it shouldn't take too long, and indeed this is already finished. So if I now go into the hijax folder, I can see I have a local copy now of the data and the gallery of images, along with all of the folders that contain the code starting points and ending points of each of the lectures. Now, we're not quite ready to run this code yet. There's one more step, that is we need to set up a virtual environment. And so there's instructions for setting up the virtual environment here in the repository. I like to use the tool UV to manage my virtual environments. You can install UV if you like by looking at the instructions on the UV website, but I already have it installed, so for me, I just need to UV venv, and I like to call all of my VMs venv. And then I can have some shell commands that will automatically source them when I change directories. But if you want to manually source them, you would need to source the venv bin activate, and then you'll see we have this crucial, my shell is configured to tell me when I'm in a virtual environment, and we are now in the virtual environment, so that's what we need. But this is just an empty virtual environment. We're still going to need to install the actual Python libraries that we need. It looks like we've got Python version 3.13, which, any sufficiently modern version of Python should be enough for following this course. It shouldn't matter too much, but 3.13 will definitely be enough. Now I'm going to install the virtual environment, or all of the dependencies of the virtual environment using UV. So for that I need to use pip, but UV's version of pip, so I'll UV pip install the requirements file. This requirements.txt came along with the files that I cloned. And so UV is lightning fast. This will only take a moment to download and install all of the dependencies, including NumPy and, crucially, JAX. Now, there's one thing to mention is that this is installing JAX to use the CPU. If I wanted to install JAX to use a GPU with CUDA, I might need to use a slightly different command. And if I was doing this on a TPU virtual machine, I need to use a slightly different command again. But all of the code should run on CPUs, and we should still see speed-ups from JAX, even on a laptop like my MacBook Air with a M2 chip. And so that should be enough for today. And so let me go into lecture 0 and show you that now I should be able to run the first example. And we will run this program with NumPy, and we'll figure out what these strange symbols mean in the first lecture. I'll see you there. Bye.